In this video, we're going to continue talking about quadrilaterals on the coordinate plane. In the previous videos, we were looking at comparing slopes of opposite sides and comparing slopes of consecutive sides that were next to each other. And in this video, we're going to continue with that, but we're also going to look at the slopes of the diagonals of the figure. And we'll talk about what happens if the slopes of the diagonals are also opposite reciprocals, meaning that the slopes would be perpendicular, and what kind of figure that would make it. So we want to determine what kind of quadrilateral ABCD is with the given coordinates, and then we'll justify our answer with sound mathematical reasoning. So let's start by graphing the points. We've got point A is at 0, 0 at the origin, and we have B is at 3, negative 3, and C is at 6, 0, and D is at 3, 3. All right, and let's connect these. Now, for these types of problems, we do want to look at the shape of it and see if we can figure out what it looks like, and then we'll justify it with our mathematical reasoning. So this sort of looks like a square. Mine's a little bit off because I don't have the grids on my graph. You should have them on your graph. But anyway, this is point D. Let's take a look at all the different slopes. So we've got the slope of AB, and I would just recommend using your graph to mark these off. So our rise over our run would be up 3, left 3. So up 3 is plus 3, left 3 is minus 3. So that's negative 1. And then let's just go around the figure there. So we've got the slope of BC. So again, that's up 3, right 3. So that's positive 3 over positive 3, which is 1. And the slope of CD, up 3, left 3. So that's 3 over negative 3 again, which is negative 1. And the last one, the slope of AD, so up 3, right 3, positive both directions, so that's positive 1. Now, we can see here that the opposite sides, AB and CD, are equal, and BC and AD, those are the other pair of opposite sides, are also equal. The slopes are equal. So based on the fact that the opposite sides have the same slopes, and therefore are parallel, we know that this at least has to be a parallelogram. And since the adjacent sides are opposite reciprocals, so AB and BC, negative 1 and 1, those are opposite reciprocals. BC and CD, opposite reciprocals, and so forth. So these slopes indicate figure is at least a rectangle, since opposite sides are parallel and consecutive sides are perpendicular. So now we kind of looked at it and decided it was a square. So what we need to do now is now check slopes of diagonals. So let's do that. So one of the diagonals is AC. The slope of AC, we can see that that's horizontal, so that's going to have a 0 slope. And the slope of DB, we can see that's vertical, so that's going to be undefined. And we've talked about the fact that 0 and undefined are opposite reciprocal slopes. But we can see that they're also perpendicular if we drew those in. One's vertical and one's horizontal, so they're perpendicular. So since diagonals are also perpendicular, quadrilateral is a square. Okay, so we did three things here. We found out that the opposite sides were parallel. Number two, we found out that the consecutive sides were perpendicular. And number three, this is the new thing for today, we found out that the diagonals were perpendicular. If all three of these things are true, then it has to be a square. So ABCD is a square. And just some stuff to start getting us ready for the final exam, reviewing types of symmetry. So if we look at this, we can see it's got reflectional symmetry. We've got a bunch of lines of symmetry. And it also has rotational symmetry. So reflectional and rotational. All right, and if you have any trouble with this, feel free to go back and watch those videos or check your old notes or get some help from me or the other teacher in class or your teacher. All right, how many lines of symmetry does it have? So I'm going to draw a little sketch here of our square. It looks something like this. And I can draw 1, 2, 3, 4 lines of symmetry. Lines of symmetry. Remember, these lines of symmetry divide it into mirrored halves. All right, degrees of rotation. Again, we'll draw a little square here. If I put a point in the middle, I can rotate this point over to there, and the figure will look exactly like it does now. Or I could rotate it over to there, or over to there, or back to the beginning. So there are 4 times that I could rotate it and have it look exactly like it did at the beginning. So 360 divided by 4, it has 90 degrees of rotational symmetry.